Hey there, Internet Explorers! Ever wondered how your computer finds its way around the vast expanse of the internet? It's like having a phone book for websites, but instead of names, we use IP addresses. But remembering those long strings of numbers? Not exactly user-friendly. That's where DNS swoops in to save the day. DNS stands for Domain Name System. It's the magic that translates human-readable website names like Google.com into those IP addresses computers understand, like 172.217.160.142. Without DNS, we'd be stuck memorizing complicated number sequences just to check our email. Think of it like this: you want to order pizza from your favorite place, Pizza Palace. Instead of trying to remember their phone number, you just look them up in your contacts list. DNS does the same thing for your computer, connecting the website name you type in with its corresponding IP address. So, next time you effortlessly browse the web, give a silent thanks to DNS. It's the unsung hero working behind the scenes to make our online lives a whole lot easier. Now that we know why DNS is important, let's break down how it actually works. Imagine you're looking for a website, let's say Facebook.com. Your computer needs to find its IP address to connect. Here's the step-by-step process. First, your computer sends a DNS request to your ISP's DNS server. This is like asking the librarian for the location of a specific book. If the ISP's DNS server doesn't have the answer, it asks a root server. This is like the librarian checking the main catalog. Next, the root server points the ISP's DNS server to the appropriate TLD server. TLD stands for top-level domain like .com, .org, or .net. It's like finding the right section in the library. Then, the TLD server directs the ISP's DNS server to the authoritative name server for Facebook.com. This server holds the actual IP address for the website. Finally, we've found our book. The ISP's DNS server gives the IP address to your computer and you're connected. You can now browse Facebook to your heart's content. Just like a library has different types of resources, DNS uses various records to store information about a domain. Here are some of the most common ones. An A record is the most basic record, connecting a domain name to its IPv4 address. It's like the book's title and its location on the shelf. Then we have AAA records, similar to A records, but for IPv6 addresses. As the internet grows, we need more addresses. A CNAME record stands for canonical name record and creates an alias for an existing domain name. Think of it as a nickname for a website. An MX record specifies the mail server responsible for handling emails for a domain. It ensures your emails are delivered to the right place. Lastly, an NS record identifies the authoritative name servers for a domain. It's like knowing which librarian is responsible for a specific section. These are just a few examples, but they highlight the diverse ways DNS organizes and manages domain information. Section 4. Types of DNS queries. When your computer needs to find an IP address, it can send different types of DNS queries. These queries determine how the DNS server responds. Here are two main types. This is like asking a librarian to find a book and bring it to you. Your computer asks the DNS server for the IP address, and the server does all the work to find it. This is like asking for directions to a specific book. Your computer asks the DNS server, and if it doesn't know the answer, it provides a referral to another server. Your computer then contacts that server and repeats the process until it finds the IP address. Section 5. DNS caching and TTL making things faster. Imagine having to ask for directions every time you wanted to visit the same place. That would be inefficient, right? DNS caching solves this problem by storing recently accessed DNS records. When your computer requests an IP address, it first checks its own cache. If it's not there, it asks the DNS server. The server caches the response, so the next time someone asks for the same address, it can provide the answer immediately. TTL, time to live, determines how long a DNS record stays in the cache. It's like an expiration date for cached information. Once the TTL expires, the cached record is discarded, and the next request triggers a fresh lookup. DNS caching and TTL work together to speed up website loading times and reduce the burden on DNS servers. Section 6. Keeping DNS secure, a quick look. While DNS is essential for internet navigation, it's also vulnerable to security threats. Hackers can exploit DNS to redirect users to malicious websites or intercept sensitive information. Here are a few ways to enhance DNS security. This protocol adds digital signatures to DNS records, ensuring their authenticity and integrity. This encrypts DNS queries and responses, preventing eavesdropping and manipulation. Choose a DNS resolver known for its security practices and commitment to user privacy. By implementing these measures, we can make DNS more resilient to attacks and protect ourselves from online threats.